So Dr. Lin Ching-Yung, you spent the first 20 years at IBM as a chief scientist and executive. So what are the key insights you learned from IBM that made you to start Graphen AI?
So in IBM, our company's goal is already pursuing AI for decades, right? From our early days to do the deep blue, the one for the chess, and also in the early 10s that we do the IBM Watson to be the Q&A system that be the human. So it's been always a major target for IBM to advance the state-of-the-art AI. So actually in IBM, my days I led a lot of the AI projects worldwide, and then since the early 2000s. So we do a lot of them. The part of the reason that I left IBM was that so I can more or less I can do it with my agenda about to make things happen, rather than immediately pursuing so many different type of areas that in IBM we have to handle as a chief scientist. So that was part of the reason that we did that. But it was actually a very good thing because in IBM we actually do projects with all the customers worldwide, almost all kinds of the big governments, big companies, in all kinds of industries. So we actually gain a lot of experience by working on the ground with them to solve the customers' problems.
Okay, so at COMPUTEX this year, you're presenting a digital human customer service system. What makes it human-like?
So actually it started from our research about it's almost 12 or 13 years ago. So that time we have been the first team to let the computer to be able to see the image, and they can also have a feeding of the image, saying, "Oh, this picture is so peaceful, and I love it." So computer actually can do this kind of thing. So we actually have been working on this kind of understanding the humans. So then we can make the feel, and also make the eye contact that what we as a human we would do. So when we expect that we are doing this digital human, we make the avatars to be like a human. So you need eye contact, you need facial expressions, you need your personalities about the way you are talking, and then also the actions and the tones. And the facial expressions, you need to be very detailed. Otherwise, that is just maybe a cartoon. So that's why that we actually seen that when the AI is coming to our life, it will be more and more it can really like a human. Maybe it can do a lot of things that people can do, and the people can feel more comfortable. So that's why we have been doing that for years to this is a digital human.
So the digital human customer support system was developed 4 years ago. That was before LLMs like ChatGPT. How has the industry as a whole changed?
It was a very interesting one. Is that the one that we can see the difference is that the large language models actually bring a major difference. Is if customers they want to ask what's the weather today, or they want to do a lot of small talks. In our older system, we actually cannot handle that. We are not trained. We are more focused on each kind of scenarios, each kind of situations. But right now, for the large language model part, it actually kind of allows us to handle other stuff that is we consider is not necessarily relevant to the usage, but they actually can help the user to be. If I have a small talk, we'll have small talk with you. So it can handle this kind of thing. And also it kind of help a little bit on kind of make the ambiguous talking to make it more recognizable. So because right now for these large language model ones, it actually has a better capability to reasoning the person's thinking behind the scene. So for example, sometimes he may just come out with a cable. And then you actually need to guess what he means he wants a cable. So you need to try to guess the context on that. And this type of models actually help to guess the context on what the users want. So that's why we can also see the latest the large language model one can complementary to what we have been doing and combine together.
So I know one of your big projects was launching Genomics last year, 2024, which promises to shorten the development time and cost on small molecule drugs. Can you explain?
Yeah, we actually start our drug development area about 2019, 2020. So at that time, when the COVID started, we were able to analyze the COVID variations all over the world. We actually provide the real-time tracking system on that. So in the last 5 years or so, actually this AI technology is start to be able to really model how the protein is actually the biology's smallest parts. You think it's a part. And it's the first time the human can really predict what is its structure. So because previously in medical domain, you actually do not know what your parts looks like. So therefore in the medical domain, it has been always kind of the try and error type of way to create drugs. But right now, the latest AI, it becomes possible to predict the structure, and we do a lot of work like predict the function, predict how the drug can be associated in our body. So we actually create right now it's called a multi-agent system, that with all the experts that are working together 24/7 to come up with the best solution, the best structure to treat a disease. So it actually it can do things that traditional drug development probably needs 7-8 years to do. We can do it in 2 weeks. So and then it's a significant cost reduction, maybe only 1/1000th of the original cost on that. So therefore, we are seeing right now we are in this kind of front of the revolutionize the way the drug development can significantly help the human's health.
How much of a role is AI playing in drug development currently, and how do you think it's going to grow in the future?
I think that you can see that companies or the worldwide competition will just jump to this area because as I mentioned previously, the older method was try and error. But right now, we can really to predict how good the new molecule that we generate, how it will function in the human's body, how it will impact the humans, how it can treat on that. It becomes predictable. So a lot of the work that I talked about a few years ago, in the last several years, are all it's right now the Newton moment in biology. So what does it mean Newton moment? Because when he found the law of gravity, then human beings was the first time can really predict the physical movement. So then after that, there was an industry revolution. Then it was our life today. So without Newton, our life should be the same as our ancestors 300-400 years ago. There should not be any difference. So right now we're actually in this turning point in biology. It becomes predictable. So therefore, the human disease in the coming future, it becomes predictable. You know how to treat it precisely. No longer try and error, blindly test it, 10 years, 20 years of drug development. No. So it totally becomes like what we see in the physics. In the fourth industrial revolution, we are seeing another beginning of really the industrial revolution. Finally, it comes to biology.
So you talk about predictability, but how can early detection really be achieved through AI? How realistically is it for diseases such as cancer?
So for early detection on the disease, it becomes actually one of the work that we did was for the whole genome sequencing. And doing the whole genome analysis about try to predict what's going on your genome, on your particular mutations, how it will function. So for example, like in COVID, we actually can predict exactly if something happened, some mutations happen, what will be the impact on that. So therefore, in other words, that we don't even need it to happen. Before it happens, we already predict. So in that time, we actually can design the machines that can deal with future mutations, even it does not happen yet. So in other words, that for humans, the disease is not only the early detection, but it can be not just using an image to detect a small, tiny amount of that, but it can try to predict based on your genome mutations and then how your genes already changed based on the environment. So therefore, we can detect that and then to even before it happens. So it's not even early detection, it's before it happens, we actually can detect that.
So AI seems to be the buzz on the floor of COMPUTEX for the past several years. But by your estimation, we have about 10 years for AI to achieve human-level knowledge and logic. How do you define that, and what are you basing that information on?
So a lot of our, so for example, I'm teaching the advanced AI this semester in Columbia University. One of the major part in my class was talking about how we can achieve the artificial general intelligence. It's called the AGI. So AGI is a term that try to describe the AI as just like a human. Okay. So actually include all the things like all the perceptions. You have perception. You actually can do the reasoning, try to understand what you may want to say, try to figure it out, try to see and also about the emotions that AI can have emotions, can figure that. It can about its own planning, that I think about how to plan that, it can do that. And furthermore, it can have something kind of consciousness. So it knows the boundary of itself and it knows the boundary of other people. So maybe entered in the area. So after that, you actually can see what AI is doing, what AI can do is actually similar to what human can do. Okay. We do see this kind of thing actually. Previously, I say it may come in 10 years. Right now, I guess it's actually happening now. Probably, I would say maybe in 2-3 years, you probably already can see AGI is there. We already saw the technologies that are developing right now. Actually, it's very promising to actually achieve that. You can see that. But actually, furthermore, what we are seeing is that a lot of these capabilities, what we are seeing on the AI is they are actually better than human. They're actually smarter than human. We actually have been seeing this kind of AIs, a lot of AIs working together, especially close multiple AIs. Combined together, it already has a capability more than human. So that's why that not only the general AI, AGI, we actually see the artificial superhuman intelligence actually is also there. It's also there. So very soon that we predict, yeah, I would say in 10 years you can see AI are smarter than us everywhere. It's already here. It's only now, so you can see it's happening. Yeah.
So you're cutting your prediction by half, right? And
sort of, yeah.
What are the key progress or AI or compute that are necessary to make this happen?
Yeah. A lot of things right now, because the competition worldwide is actually very, very harsh. They are very competitive because right now people actually can see how powerful these AIs can be, how capable it can be, right? So you can see all the big companies they put their resources into that. They buy the hardware, of course, then Taiwan benefit on that. Then collect a lot of data to training on that. And furthermore, we can see the recently, companies like Meta, they release their trained models. So then previously for small companies, they do not have the resource to buy the huge amount of the hardware. Then suddenly they are able to do a lot of things big companies can do. Because that the world model, the most difficult one is the trained world model. That is AI has a general capability of a person. So right now big companies, they are releasing that for free for other people. So therefore, you can see all the researchers right now are capable to create the AIs on top of others. So you can see this kind of progress. Actually, right now we can see it's exponentially speeding up so fast that I mean, in my class, I actually need to handle the materials. It may happen like a day ago, a week ago. It's so fast. Right now it's so fast. That's why that the previous what I predicted the time on that. Right now it's actually even much faster than that.
So with the pace of AI growing, what is Graphen AI going to tackle in the field of AI next?
So for us, we actually have several key fields, right? So I mean, we do the finance AI that we already did for decades. We do this drug design and also medical treatments. So this is another area. And the third big area is AI agents and the robots. So we actually have been, the reason why that we didn't try to jump into humanoid robot at the very beginning was that it actually is very expensive. The hardware was to assemble a humanoid robot, you actually need, I don't know, 60K, 80K, 100K US dollars to assemble one prototype. It is quite expensive. So that's why that we started with a digital human, that to have a virtual ones, to be able to interact, to talk with people, to help them on all kind of work that a human can do first. and then we will migrate that. Later on, we are actually adding the arms. We already have the legs. We are adding the arms to see what the physical humanoid AI can do. We are actually adding on that. So in other words, that we can see, gradually, I mean, Graphen, we actually also help to make this happen. It's about the AI agent robotics applied to all kinds of fields everywhere, being in the business side, in the retail, in the tourist, in the energy. I mean, you name it, we have all kinds of applications. Yes.
So lastly, before we go, at COMPUTEX this year, what innovations have caught your eye and why?
It was a very interesting one because this year COMPUTEX, you probably start seeing more putting robots there, the robotics there. It was actually a puzzle for me about where are we really are in robots, right? Because if you go around this one, the majority of companies are actually still the computer, right? So where is the robot? It was a very interesting this one. But we can see the trend is coming. Right? We do see like NVIDIA is trying to push the next generation to be not just the computer, but the physical AI that go to the robots area. And with NVIDIA's leadership, that a lot of Taiwanese companies try to jump into the area, try to work together with NVIDIA to make things happen. So we can see the start of the new areas coming. And last week I actually was in the Automate in Detroit. It was the largest the industry robot show in the world. It was all of the robotic arms there, and almost I don't think I see the NVIDIA booth, and none of them, almost all of the here and over there are not overlapping. But right now we are seeing this this community is trying to enter that community, and let's see. It will be a very interesting trend about how this AI make robotics, how you jump into automated area, how you will jump into the industry areas. You will be very interested to observe this trend in the coming years.